Thanks to lecturer. My name is Pogulendran from class 21F. In this assignment mainly contain three sections, which is introduction, data analysis and conclusion. Regression is a statistically method to determine the strength and character of the relationship between one dependent variable and independent variable. Simple linear regression used to estimate the relationship between two quantitative variables. Multiple linear regression used to determine a mathematical relationship between several variables. Our group chose dataset 3, which is baseball. First of all, to conduct a simple linear regression analysis, we need one independent variable and one dependent variable to investigate and explain the relationship between two variables. The graph shows a scatter plot of data between variable x, which is chosen by x1 run score and variable y is battling average. The plot pattern shows that the possible relationship that may exist in positive linear relationship because when put a straight line it forms upwards as they are in a relationship between two variables. The correlation coefficient, which is regression, shows 0.825, which is can be said to be strong positive linear relationship between x1 run score and y battling average. Because the range regression is closer to the correlation coefficient 1 when r is positive to the line slope upward to the right or as the value of x increased while y increased. Based on the regression data that we created in Excel, it can determine the values for B0 and B1. By using the available data, the equation becomes like if in Major League Baseball players reach 0.144 in run scored and they can get 0.374 batting average. Based on the diagram above, the p-value is less than the set significance level of 0.05. Therefore, we reject H0. The test results are statistically significant at the 5% level and provide the very strong evidence against the null hypothesis. The relationship between variable x1 run score and y battling average obtained are to 0.6805, equivalent to an increase of 68.05%, which is not too high and low value. The regression line explains 68.05% of the variation in y variable and implies that the y variable can be predicted without error from the x variables.
R squared for all variables found is be 0.860 when it is high R squared close to 100%, which means it is overfit. Based on the table, the variance inflation factor, which is PIF for x1, is the highest compared to x2, x3, x4, and x5, which is 3.055. This VIF is more than 3 and shows no correlation between the independent variables and the other variables because the VIF is the less than 5 or 10. So it means there will be no multicollinearity. Here is the comparison between two models, which is model 1 is simple linear regression and model 2 is multiple linear regression. We can choose that R for the NR model is higher, which is 0.927, which is closer to 1. The probability of positive quality and strong relationship compared to S and R is only 0.825. Next, the R square value shows that NR is also higher, which is 86% compared to S and R, which is the R square is 60.05%. Due to the predicted R square between two models, thus the best fit models for the data set 3, which is best boy, is the multiple linear regression. This is because the straight line M and R shows that there is strong and positive relationship between variable y, weighting average, and variable x2, x3, x4, and x5, and the line is a well-formed and the points are very close. To make prediction the best model, which is M and R, it is necessary to use the equation. By using the equation of the M and R, we can make a prediction with Y, and then the run score of the times at bat, double of time at bat, triples of time at bat, home runs of time at bat, and try out of time at bat will predict that Y hat, which is batting average by players, found as much as 0.282. The p-value for all variables x is less than the set significant level of 0.05. Therefore, we reject H now. The best results are statistically significant relationship between batting average, run score at times at bat, doubles of time at bat, triples of time at bat, home runs of time at bat, and strikeouts